So let's check out chapter 7, which deals with sampling distributions. This kind of laid the foundation for all the confidence intervals and tests that we did. So we started talking about parameters. That's a number that describes a population. P for parameter, P for population. It's important to recognize on your formula sheet, they list out the parameters for proportions, for means, for regression analysis. So all of that is there. Statistics are numbers computed from a sample. And the whole left column, that's your statistics that you can see there. So knowing those are on there. So we use these statistics to estimate parameters. So what's a sampling distribution? It's the distribution of all the possible values of the statistic for all the possible samples that you could possibly create. So that's a horrible explanation. Let me give you a better one. So say we have, I don't know, numbers of hours worked by 3 employees. And if I want to know the average number of hours worked, I would take every possible sample of, say, size 2, and I'd calculate the average. So the average here would be 11, the average here would be 13, and the average here would be 12. And if I graph these, that would be the sampling distribution because it's every possible sample mean from size 2. So that's what these pictures are essentially saying. You're going to get a different mean every sample, and then you create your sampling distribution. If we're dealing with means, how do we check the shape? When we do CVS, that's the central limit theorem. That's your normal large sample condition. Is the sample size at least 30? If it is, the central limit theorem applies. If not, you're going to have to create a box plot and see no strong skewness or outliers. If we're dealing with a proportion, how do we check to see if the sampling distribution is approximately normal? This is your large counts condition. Unless you have chi-squared, which we'll get into in chapter 11, you need at least 10 successes and 10 failures. Ideally, you want your estimate to be low bias and low variability. Low bias means it's very accurate, that the mean of the statistic is equal to the mean of the parameter, the true mean. And low variability, we know as we increase sample size, we have less variability. We want to be precise and we want to be accurate. So this is just a picture of the central limit theorem. So you have the population distribution, it's strongly skewed. You take a small sample size, your sampling distribution is still going to be skewed. But if your sample size increases enough to 30 or higher, the shape of the sampling distribution is becoming approximately normal. So that's it for chapter 7.